Hello, today we are talking about logarithms, and while that's a new word for you and a new idea, it's going to be based and connected on what we've been talking about with exponents and exponential functions and things like that. So I want to show you the connection. Hopefully you kind of saw it in the pictures today, but first of all, let's define what a logarithm is. So log is short for logarithm, and we just say log base b of a, equals x means b to the x power equals a. Okay, so to get you some terms here, the b stands for the base. So this is the base. You see why it's the base over here. So the base in log form is written as a subscript, so you'll see log and then a number down low. That's the base. A stands for argument. I actually didn't know that word. Oh no! There we go. It stands for argument. I didn't know that word actually until I started teaching this last year, but you could also think of it as A for the answer. So this answer over here. So argument. Or you can think A for answer. So that's the argument. And the x is the exponent. And you see it as the exponent when it's written in exponential form here. So this is the exponent. X for exponent. Okay, so the way you read this, if you see a logarithm, the way that you read that is you say that you're taking the log base b of a and that it's equal to x. Okay, so that's how you would read it. Log base, and then you read whatever's down there, and then you say of what that number is for argument. So let me give you an example of this. Let's say we had log base 3 of 9, and we want to see what that would be equal to. Okay, log base 3 of 9 is how you would read that. So let's take that and convert it over to the exponential form so we can see what's going on here with the logarithm. In your packet you should have a foldable that looks like this. Yours won't be green, yours is just white. And yours isn't laminated, mine's laminated, but anyway, on this foldable I have it so that you can put the numbers in their spots, and then you can identify with the little flaps what each one represents. So I'm going to put this on my foldable here. Log base 3 of 9 equals x. Okay, so this is the problem that we're working out here. Log base 3 of 9, and we want to see what that is equal to. So which number is the base here? So if I fold my flaps up, the base is down here at the bottom. The base is the bottom number, and that is the 3. So if I'm going to write this in exponential form, this means the base is the 3. Which one would be my exponent in this problem? Well, that would be over here where the x is. So my exponent is the x. That's what I don't know in this problem. And then the answer is the argument. So the number that I see right here, log base 3 of 9 in this case. That 9, it's called the argument. It means it's the answer to when we did this exponent. Like, what did we get? 3 to the something gives us 9. Okay, so think about that. 3 to the what power would give you an answer of 9? Well, that would be 2. So this would have an x value of 2. So x equals 2. So kind of getting ahead. We're going to be solving logarithmic equations later, but you can see how it's going to work once we do the conversion. So the main thing today is going to be converting them from logarithmic form to exponential form and vice versa. Okay, so there's that. So, I need to give you a couple of restrictions on logarithms. So a couple of limitations here. So restrictions. The base, so in the format I gave you, it was abbreviated as B, needs to be greater than 0. Okay, so that means it's going to be positive. You're going to use positive bases. Okay, so that subscript number, log base, whatever, the little number, that's going to be something that's a positive. And there's also a rule that it is not allowed to equal 1. And the base cannot equal 1. There's a very good reason for that. If I had a base of 1, if I was going to take 1 to the different powers, well, what's 1 squared? That's 1. What's 1 cubed? Still 1. What's 1 to the 4th? Still 1. What's 1 to the 10th? Still 1. It's not exciting at all, okay? So we don't use a base of 1 because it doesn't, like, do anything. So that's the 2 limitations on the bases. And let's do some more example problems, and then I'll tell you a little bit more. So let's say that we had to find log base 7 of x, and that's equal to 2. I wonder if we convert this into the exponent form, if we can figure out what this x would be. So let's take our little foldable and fill in numbers here. So I have log base 7 of x equals 2. So I want to work on converting this over to exponential form. So what am I going to use as my base? Well, the base is the 7. So this will be, this means 7 to the, what's my exponent going to be? That's the 2. The logarithm tells you the exponent. So 2 equals, and then the argument is what I need to put on the other side of the equal sign, and that's x in this case. So I have an x over here. Well, what's x then? 7 squared? We're talking 49. So x equals 49 there. Let's see. Let's try another one. Let's do log base 2 of, oh, I know. How about 1/4 equals x? So let's try this. This looks a little tricky. Log base 2 of 1/4 equals x. So I have everything placed on here. So what is my base? So the base would be under this flat. So the base is 2. So I have 2 to the, what tells me my exponent? What's over here? So 2 to the something equals, and then my argument is what needs to go on the other side of the equals line, and that is 14. Or not 14, 1/4. So is it possible to take 2 to some exponent and get the fraction 1/4? What type of exponents make you flip things over? Take the reciprocals of them. Do you remember? That is negatives. So this is going to have a negative exponent. So that x is going to be a negative number here. Now, what would you do to a 2? 2 to the what power would give you a 4? It'd be 2 squared, right? So since this is 1/4, the x value here would be a negative 2. I can check that by placing that negative 2 right up here in the spot of my exponent. And 2 to the negative second power. Does that actually come out to 1/4? Yes, it does, because 2 squared is 4. Flip it over, you get 1/4. So there we go. Now, there are a couple of special logarithms, log base 10 and the natural log. So let's talk about those next. Oh, also, I did look up what logarithms means, and it was some Latin word, and it didn't really make a lot of sense to me. I think they should have called them unexponents. I think that would have been better, because it's reversing what an exponent does, basically. So I think that would have been a good name. Better than logs. That's weird. But whatever, they didn't ask me. So the two special logarithms are log base 10 and base e. Okay, so the reason that 10 is special is that we have a base 10 number system. Like all of our place values, like if you move over to the next place value in a number, you're going up by 10, like a 9 and then a 90 and then a 900 and then a 9,000. You're like multiplying by 10 every time you move over a spot. We base everything on 10. We have 10 digits. So 10 is the most common base to use. So you know how, so I'll just say it this way. You would think we would just write log base 10 of like x if we wanted to find something, log base 10. But mathematicians, you know how they are. You know they don't like to write more than is absolutely necessary. Well, they're like, 10 is the most common one. So if I just put log of x and I don't put a base, you just assume I'm talking about log base 10. Okay, if I don't say otherwise, it's a 10. Okay, so if you see this, just log x sometime, you see that, it means log base 10. So feel free to go ahead and pencil that 10 base in there if it bothers you that they're leaving it off. They kind of do it with square roots too. You know how if you have like the square root symbol, if they don't put a number out front, you are just allowed to assume they mean square rooting, because square rooting is the most common kind of roots to take. But if they want you to do something different, they'll put like a cube root sign out there, or a different number. It's like that. They're like, if I don't tell you otherwise, assume I mean 10. Okay, so that is one of the special bases. The other one is e is a special base. We talked about the number e, my other favorite number besides pi, when we were talking about continuous growth. So since it comes up in exponential functions, it's going to come up in logarithms, because logarithms are like undoing exponents. So you would think they would just write it like this. You would think they would just put log base e of whatever. But they don't. They decided that it was so special, this is such a special number, that they're going to give it a whole special name. And they call it the natural logarithm. So this is the natural logarithm. And it occurs in nature. So natural logarithm. And they abbreviate it like this, ln of x. So log base e of x is the same thing as saying I'm taking the natural log of x. And I don't know why they abbreviated it ln when you say natural logarithm, you would think NL, but nope, it's ln. And it means, but when you read it, you still say the natural log of x is what you're taking there. So when I saw that, when I was first learning about these, I just took it and converted it into log base e, because that made more sense in my mind to just think about it that way. It means the same thing. So this special name business, they do this with circles too. Everything with circles gets special names. Like, instead of just calling it the perimeter, they have to call it the circumference, things like that. So anyway, those are the two special cases. So let me show you one of those. I'll show you one of each. If I say, let's take the log of 100 and figure out what that would be. Like, wait, it's missing. You didn't tell me what the base is. Okay, if I didn't tell you what the base is, we are allowed to assume we're talking about a 10. So this would mean 10 to the sum power is going to equal 100 because 10 is my base, x is my exponent, and 100 is the argument. And so 10, what would I have to do to the 10 to get 100? That would be squaring it. So x would equal 2. And then let's say we had the natural log of 3 equals x. If you wanted to convert that into exponential form, I would take an extra step and write it like this. Log base e of 3 is what it means when they say the natural log of 3 equals x. Because then I could use my little foldable and figure out where everything goes. So this would mean e is my base, x is my exponent, and 3 is the argument. So e to the x equals 3 is what that would be saying in exponential form instead of in logarithmic form. So, okay, I think that's everything I need to tell you. So remember that Jesus loves you, and so do I, so do your math.